Hi students, welcome back. Today's topic is pulleys. This is the last section of the chapter machine. In this video, we will study what is a pulley, then the combination of pulleys like fixed pulley, movable pulley, compound pulley. Then we will calculate the mechanical advantage velocity ratio of each types of pulleys, and then at the end we will see how the weight of the pulley determines its efficiency and velocity ratio. So let's start. What is a pulley? As you can see in this figure, pulley is simply a wheel with a groove in it and a rope in the groove. It is a simple machine which makes work easier because it changes the direction of motion to work with gravity. Let's see. Earlier this load, the direction of load was upward, right? And the direction of gravity is downward towards the earth. So earlier it was, if you lift the load directly up, it was doing work against gravity. Now with the help of pulley, you can apply the force with the gravity. So it makes work easier. Let's see the types of pulleys. Now the pulleys can be designed in various types. One, single fixed pulley. Then second one, single movable pulley. Then combination of pulleys can be possible. There are two combinations which we will study here. One is one fixed pulley with several movable pulley and a block and tackle system. So let's see these types of combination. First one, single fixed pulley. As shown in this figure, a pulley which has its axis of rotation fixed. This one is fixed, is called a single fixed pulley. What is this single fixed pulley used for? It's used for lifting a small load such as water bucket or a basket. There is always some amount of friction between the string and the surface rim of the pulley which rotates the pulley. But in this case, we consider that this pulley is ideal. Let's calculate the mechanical advantage of the pulley. Mechanical advantage is the ratio of load by effort. First of all, load is a force. Effort is also a force. Now we will study another force which is known as tension force. Tension force. What is tension force? It's marked by T. In physics, tension is the force exerted by a rope, string or cable or similar objects on one or more objects. Anything pulled, hung or supported or swung from a rope, string, cable is subject to the force of tension. Now here we have a rope, so there is a tension force existing. And how does the tension force acts? If the mass or the force is acting downward, then tension force will act upward here. Tension force is always a restoring force. Let's see, this is a spring, right? When it is pulled in this direction, the load, we have applied a load here or an effort here. So this spring is pulled in this direction. So what will be the restoring force direction? Restoring force will try to pull the string to its original position. So restoring force or tension force will act in this way. So if the load is being pulled down by the rope, how the tension force will act? It will act upward. Similarly, effort is applied in this direction. So what will be the tension force? Again here also upward direction, right? Now let's see. At equilibrium position, what will happen? At equilibrium or balance position, I can write this load is balanced by tension force that acts upward. Load is equal to tension force. And what will be the effort here? Effort is also equal to tensional force or the force acting upward at equilibrium position. How equilibrium position? Plus force minus force is equal to 0. Then only it balance position. So at equilibrium or balance position, load is balanced by the tension force and effort is also balanced by the tension force acting on the string. So what will be the mechanical advantage here? Mechanical advantage is load by effort. Load is T, effort is also T. So what will be the mechanical advantage? It's 1. Now let's see what is the velocity ratio. What is velocity ratio? Velocity ratio is the ratio of distance covered by effort by distance covered by load. Suppose let's say effort covers a distance of D. The same distance will be covered by load. So D by D, that also equals to 1. Now what will be the efficiency? Efficiency is equal to mechanical advantage by velocity ratio into 100. That is equal to 100%. So considering this fixed pulley to be ideal. In actual case, there is always a friction present in the ream. So actually the efficiency is not 100%, it's less than that. Similarly, the mechanical advantage is also less than 1, but the velocity ratio remains the same. Now coming to single movable pulley. What is single movable pulley? It is the one whose axis of rotation is movable. As you can see here, the axis of rotation is movable. This one is known as movable pulley. Now again, wherever we have a string or cable, tension force acts, right? Now this string is being extended by the load. So what will be the tension force direction? It will be upward. So tension force acts upward. Now similarly here what happens? Again this string is again pulled by load which is acting downward. So what will be the tension force? It will again act upward, right? Tension force is acting upward. Now here again for calculation of mechanical advantage we need to calculate load. What will be the load here? Load is balanced by two tensional force. Here one T and here another T. So here load becomes 2T, right? Because load is balanced by two tensional forces. And what will be the effort? Effort is balanced by only 1T. Effort is equal to tensional force. Now what will be the mechanical advantage? It will be load by effort 2T by T, that becomes 2. So mechanical advantage here is 2. Here the distance traveled by effort is 2D and distance covered by load is only 1D. So velocity ratio becomes 2. Mechanical advantage is greater than 1. So it behaves as a force multiplier. Efficiency is equal to mechanical advantage by velocity ratio. That is equal to 2 by 2 is equal to 100%. This is also in case of ideal. But in actual practice, the efficiency is always less than 100% and mechanical advantage is always less than 2. But the velocity ratio in actual practice also remains 2. Whereas in practical machines, mechanical advantage and efficiency will be reduced, but velocity ratio always remains same. Now ways to change the direction of effort using a movable pulley. Now here what is the direction of effort? It was upward, right? It is difficult to lift a weight upward is difficult. We wanted to change the direction of effort using a pulley. Here is a movable pulley and the effort was like this. So we want to change the direction downward. We will attach another fixed pulley at this end. Let's see the calculation. Effort here is balanced by T. Always a tension force acts. Now first load. Load is balanced here by 2T, 2 tensions. What is effort balanced by? Only 1T. Effort is equal to T. So what will be the mechanical advantage? It's 2. Velocity ratio is effort moves here 1D, here 1D. So 2D and weight moves only 1D. So velocity ratio remains same. The same is here. In single movable pulley we had velocity ratio 2, mechanical advantage 2. If we only change the direction by putting a fixed pulley, the mechanical advantage remains same, velocity ratio also remains same. In actual machine, mechanical advantage is less than 2 due to frictional forces that exist on the ream and also due to the ball bearings of the pulley. Efficiency will be how much? MA by VR into 100. That's 100%. But in actual practice, it's less than that. Now, combination of pulleys. First of all, why combination of pulleys is done? In order to lift a heavy load, we require a pulley system of mechanical advantage more than 2. So, a single movable pulley is not enough. Therefore, a combination of several pulleys with strong thick string is used. The combination can be of 2 types. First one is, let's see this one, using one fixed pulley as shown here, one fixed pulley and several other movable pulleys as you can see in this figure. And the second one will be the block and tackle system. Now let's see this using one pulley and several movable pulley. In this case, let's calculate again the load. Now let's see this diagram carefully. Now here the weight is balanced by tensional forces here, T1 and same T1 act here. Here what happens? Here T2 force acts and here another tensional force acts, T2. The same, because the same side balances this pulley. Now the C is balanced by T3 forces which acts on either side. Again this pulley is balanced by T3 forces which acts on either side. Now the load or W is balanced by 2 forces T1 on both sides. So let me write here, mechanical advantage is load by effort, right? Now first, load or the weight is equal to load here. Now the load is balanced by 2T, right? 2T1, T1 plus T1, it's 2T1. So I can write T1 is equal to L by 2, right? Now again, now this T1 force is equal to how much? Again T1 is equal to, T1 is balanced by 2T2, right? 2T2. That implies T2 is equal to T1 by 2, right? Now again T2 is balanced by T3. So 2T3. That implies T3 is equal to T2 by 2. This effort E is equal to T3. Now T3 is T2 by 2. That is equal to, what is T2? It's T1 by 2. So I can write here T1 by 2 into 2. That is T1 by square. Now that is, what is T1 again? L by 2. So I can write here, instead of T1, putting here L by 2 to the power 3 cube. Now T3 is L by 2 to the power 3 and E is equal to T3. Now we know from here that T3 is equal to L by 2 cube. That implies L is equal to 2 to the power 3 T3, right? Now mechanical advantage is load by effort. What is load? 2 to the power 3 T3 by effort is T3. That is 2 to the power 3. Now what will be the velocity ratio? Velocity ratio will be same, 2 to the power 3x by x, that is equal to 2 to the power 3. So mechanical advantage and velocity ratio remains same in case of one fixed pulley and other movable pulleys. But note here how many movable pulleys are there? 3. So mechanical advantage is equal to 2 to the power n number of movable pulleys. Similarly, velocity ratio is equal to 2 to the power n, where n is the number of movable pulleys. Now in general, if there are n number of movable pulleys connected to a fixed pulley, then what will be the velocity ratio be? Velocity ratio is 2 to the power n. What will be the now efficiency here? Efficiency will be a mechanical advantage by velocity ratio, and that is equal to 1 or 100%. Note that the efficiency of the arrangement is 100% only in ideal situation. In actual practice, the weight of the pulleys and string, the friction between the bearing of pulley, both reduces the efficiency. Now what is block and tackle pulley system? As you can see, in this pulley system, 2 blocks of pulleys are used. This is a block system. Now 2 blocks of pulleys are used. One block, upper one, having several pulleys attached to a rigid system or a fixed system, and the other one, lower block, is having several pulleys movable. The upper block is fixed to the system, rigid system, and the lower one is movable pulleys. This is called the block and tackle arrangement. The number of pulleys used in the movable lower block is either equal to the number of fixed pulleys in the upper block, or it can be 1 less than the number of pulleys in the upper block. Now the tension along the entire length of the string is same. The tension remains same. So I can write the tension here T, here also T, here also T, and here also T. Now let's see how we can calculate the mechanical advantage of this one, the second diagram. Let me consider this one, as the strings are far away from each other, it would be easy for us to mark it. So here is a tension force, here also 1 T, here 1 T, and here 1 T, and here is also 1 T, right? Now let's see this figure. Now what will be the load? Load is balanced by 1, 2, 3, 4 T. What will be the effort? Effort is only T, right? Effort has only one tension force. Mechanical advantage is 4. Load becomes N into T. So number of pulleys in the block and tackle system, the load becomes N into tension. N is the number of pulleys. Now what will be the mechanical advantage? Mechanical advantage is the number of pulleys is equal to N. So total number of pulleys in both the blocks. Now let's see this diagram where we have 1 pulley at the lower block and 2 pulleys in the upper block. So what will be the load here? Load will be 3T. Right? 3 forces are balanced by the load. So 3T. What will be the effort? Effort only 1T. So what will be the mechanical advantage? Will be 3 is equal to the number of pulleys. So load is number of pulleys into tension. Right? So mechanical advantage here is equal to the number of pulleys in both the blocks. Now what will be the effort? Effort is equal to load by N, right? Effort is tension here, and that is load by number of pulleys. So this is the two formulas. One is effort is load by number of pulleys, and load is equal to number of pulleys into effort or tension. Now what will be the velocity ratio become here? Velocity ratio is also equal to N, number of pulleys. ND is the distance covered by effort and D is the distance covered by load. So VR becomes equal to the number of pulleys. Now efficiency is equal to MA by VR, that is equal to 1 or 100%. But in actual practice it is not so. Now let's see how the weight of pulley determines the mechanical advantage, velocity ratio and efficiency. Now let's say the weight of the lower block of pulley is W, lower block. Okay, now we know that effort is equal to tension force. Now the lower block of pulley means the load plus lower block of weight is equal to NT, or the number of pulleys into tension, right? Now what will be the load equal to? NT minus W. Now what will be mechanical advantage? It's load by effort. Load is NT minus W by T, that is equal to N minus W by T, or I can write N minus W by effort, right? Now this is the mechanical advantage. Mechanical advantage is always less than the ideal value. Ideal value is equal to the number of pulleys, but in actual practice its value is minus from the number of pulleys. But the velocity ratio remains same. Velocity ratio is equal to the number of pulleys. Now what will be the efficiency? Mechanical advantage by velocity ratio. What is mechanical advantage? N minus W by E by N. That becomes 1 minus W by N E. Efficiency is reduced due to weight of the lower block of the pulleys. So the more the weight, less is the efficiency. So for greater efficiency, the pulleys in the lower block of the block and tackle system should be lighter and there should be less friction. So this is how weight of pulleys affect the efficiency of the total pulley system. So thank you for watching this video. If you have any doubts, please let me know in the comment section, and if you like my video, please subscribe to my channel for more videos.